Hello and welcome to lecture 2 of the course on foundations of immersive design for AR/VR. In today's lecture, we will take a look at the history and evolution of immersive media. This lecture will be in 2 parts. So, there will be a subsequent lecture following this. In this particular lecture, we will track the history until the 1990s. The learning outcomes at the end of this lecture will be that you will be able to understand the origins of immersive media. You will be able to trace key milestones in visual immersion. You will learn how cinema, simulation and computing contributed to the field of virtual reality. You will also learn to recognize recurring cycles of innovation and hype, which have actually contributed to the growth of this field. So, my opening question to you is, well, humans have always wanted to travel without moving, experience distant worlds, simulate reality and tell stories immersively. So, is VR really a new idea? Is it something that we are experiencing only now? Let us explore this question through this lecture. First of all, we need to understand what immersive media is. Immersive media can be defined as media that creates a feeling of presence within an environment. Now, if you think about this cave painting which I have shown on the right here, which is from the Bhimbetka caves close to Bhopal in Madhya Pradesh, you can see a human with some bulls which have horns. Now, this painting dates back to more than 10,000 years ago, and such cave paintings immediately transport you to an era that is long back in the past and how people lived back then. So, in a sense, you are transported to another age, another day, another time, another space, and you suddenly may find yourself located in that space with those humans who lived long ago. Likewise, we can talk about panoramic art, cinema, flight simulators, and of course, modern day virtual reality as experienced through headsets such as this. So, all of these may create what we can say is a feeling of presence within a certain environment. The key idea here is that immersion predates computers and may even be thought about as dating back even as old back as 10,000 years ago. There has always been a human desire for immersion. This can be seen from ancient theatre, as in this picture that you can see here on the right, which is the theatre of Dionysius in Athens. This is from 4th century BCE. This is a picture I took on my trip to Greece last year. So, you can see these ancient ruins of the theatre where people used to come and sit and watch live theatre. And when you are in such an environment, you may get completely immersed by the act that is taking place in front of you and lose the sense of presence in the exterior world. Likewise, you may imagine yourself to be sat in some religious rituals where some mantras are being chanted or some religious act is taking place. Again, you get immersed in that particular act of ritual. Panoramic paintings, dioramas, all of these are examples of past work that has shown the innate desire in humans for immersion in a different time and space as opposed to where we are now. Now, modern virtual reality can be said to have taken shape in the last 2 centuries. Maybe a good point to start is 1838, when we started understanding about stereopsis. So, Brewster, Wheatstone, etc., were some examples of stereoscopes that were developed in the 1830s. Following that, there were head mounted displays that were attempted in the 1960s, and you can see the continuation into the Nintendo Virtual Boy in the 1990s. Of course, in the last 10 years, there has been sort of a VR explosion with headsets such as the one that I showed you, as in this Quest 2 headset from Meta. Let us talk about the stereoscope first. It was developed in 1838. The inventor was Charles Wheatstone. So, this stereoscope essentially illustrated how binocular vision works, that is the use of two eyes to perceive objects in the real world. Your left eye gets an image of the real world, your right eye gets an image of the real world as well, and then the brain combines them both. Now, how do we know this actually occurs? Well, this was illustrated through this device, which was developed by Wheatstone. Here you can see two mirror like arrangements, which actually can see two images which are kept to the left and the right. So, there are two images which are formed in these two mirrors, and then the brain combines them to give you the illusion of a single object. The other thing that our brain is able to do is perceive the depth in these images. So, through these images you can perceive the depth at which different objects are present. So, in a sense this can be thought of as the first consumer immersive technology. So, here what we do is we present a separate picture to each eye to induce a 3D effect. So, essentially this is the first instance where we went from 2D to 3D. We are increasing the field of view, so that the user is not distracted by the stimulus boundary. So, this is one way our brain infers the distance of objects, and this phenomena is known as stereopsis. You can see here on the right that a paper was published on this work. So, you can find the link to the same here. Paper titled Contributions to the Physiology of Vision, part the first, on some remarkable and hitherto unobserved phenomena of binocular vision. So, information is gained by observing and matching features in the world that are visible to both the left and the right eyes. The difference between their images on the retina gives you the cues about distances. Following this, there was the era of panoramas. People started experimenting with circular paintings in the 19th century. They started looking at 360-degree viewing spaces. An example of this is the panorama view of the Leicester Square. It is from the early 19th century, and you can see how a 360-degree viewing space has been created to illustrate the Battle of Trafalgar. So, this from the famous Leicester Square in London, where this battle took place. So, the goal of these panoramas was to transport viewers elsewhere, just like the paintings that you saw earlier. In 1862 came the Pepper's Ghost, which was an early example of what we can now think of as augmented reality. So, this was an illusion technique used in the theatre, cinema, amusement parks, museums, television and concerts, in which an image of an object off stage was projected, so that it appears to be in front of the audience. So, the object itself was off stage and it appeared in front of the audience. So, after the panorama views that you saw in the last slide, that gave way to some of the early motion pictures in the late 19th century and the early 20th century. So, the early motion pictures can be that are often cited are the arrival of a train at La Ciotat. You can see a still from that movie on the right, A Trip to the Moon in 1902 and Sensorama in 1952. So, these sorts of early motion pictures played a crucial role in storytelling and emotional engagement with an audience, and transported them both in an imaginative sense and as well as emotionally to another space. In this particular movie, you can see that the train is coming in from a distance on some tracks, and some of the first viewers of this movie actually thought that the train was real and was coming at them, and started running off the cinema theatre. In the 1930s, the Viewmaster was invented by William Gruber and the Sawyer's Company. This was essentially a handheld stereoscopic viewer that you can see here on the right, that displays pairs of colored photographs. It used circular reels containing 14 photographic transparencies, and it created a convincing illusion of depth through binocular vision. So, using pairs of colored photographs, you could actually get to see different photographs, and they were presented to the two eyes. So, and the brain combined them to form a single image. So, each eye viewed a slightly different image, the brain fused the images, and the users perceived a three-dimensional scene. Next, we can talk about the Sensorama from 1960s. So, this is picture of the Sensorama setup. So, the Sensorama setup was invented by Morton Haley. This setup was essentially a large booth that could fit up to 4 people at one time. It combined multiple technologies to simulate all of the senses. The key features of this setup were 3D visuals. In addition, you had stereo sound, you had vibration effects, you had wind effects, you even had smell effects. So, in a sense, it was trying to fool all of your senses and transport them into another location. Now, Sensorama matters in the development of VR, because it was sort of the first multi-sensory immersive experience. So, multiple sense organs were being targeted, and it introduced concepts which are currently used, such as presence, multimodality and embodied experiences. In 1968 came Ivan Sutherland's HMD or head mounted display. You can see a picture of that here. So, a man with kind of a headset which is connected to a mechanism which is actually transporting those images that are being seen through the headset. So, it had a head mounted display which was so heavy that it had to be suspended from the ceiling, and the formidable appearance of this device gave it the name the sword of Damocles. So, it was quite heavy, and hence it needed to be suspended through this rod that you can see from the ceiling. It was able to carry out head tracking, it had see through optics, it involved rendering, interaction and model generation. So, there were images that were being rendered and you could interact with those images, and there was an aspect of generating models that could be seen through this display. So, it used 2-inch by 1-inch cathode ray tubes, and it displayed its output from a computer program in the stereoscopic display. The 1960s to the 1980s saw a boom in military and aerospace simulators. An example of that you can see on the right, where a user is seated in a cabin where he is surrounded by glasses and a scenery on those glasses, basically, which represents maybe a terrain which one would see when flying an aircraft. So, this was inside the FA-18 Hornet flight simulator about the USS Independence aircraft carrier. So, such applications gained in popularity from the 60s to the 80s, and that included flight training, space missions training and vehicle operations training. The key elements of such simulators were that they provided you a virtual environment of an aircraft that you would fly or a military vehicle that you would use. They had user interaction similar to what you would experience inside a real aircraft or a real vehicle, and they also had the opportunity for real time feedback. So, for instance, if you are riding a tank simulator and that tank actually attempts to go over a large mound of earth and it is not able to cross it, you would get that kind of feedback from this kind of simulator as well. So, the key insight from these simulators was that these simulators drove the research into immersion in the 60s, 70s and the 80s. During this era also we saw computer graphics rising, especially from the 70s to the 80s. So, here you can see a NASA scientist drawing graphical image on an IBM 2250 computer screen with a light pen. So, key developments in this rise of computer graphics included the development of what are known as raster graphics, where the screen is scanned line by line to render an image, the rise of 3D modeling and real time rendering. Now, without this rise of computer graphics, we would not have realized the VR that we see today. Now, the term virtual reality started gaining popularity in this time, especially in the 80s. It was popularized by Jaron Lanier, as we briefly spoke about in the first lecture. The company VPL Research essentially pioneered a number of inventions which led to the coining of this term. So, they developed a data glove, iPhone and a data suit. You can see here in this image a data suit that was developed by VPL Research. The data glove essentially was an input system for computers. Then you had the iPhone, which was a head mounted display that was meant to immerse users into a computer simulation. And then you had a data suit, which was a full body outfit with sensors for measuring the movement of arms, legs and trunk. This can be said to be the beginning of commercial VR as well. The 1990s saw a boom in VR, especially propelled by expectations such as creation of virtual workplaces instead of physical workplaces, virtual shopping avenues instead of physical shopping avenues, and virtual worlds where people could immerse themselves and maybe play a computer game. So, here you can see an example of such a setup from the 90s, where you can see a user on a rather bulky game simulator, and you can see a display in front of him, which is actually this display is then being sent into this headset. And if you look at this headset closely, you can see the view here. This is how the headsets from the 1990s looked like. While there was a boom in the early 1990s, the reality was that there were some limitations. Because of these advancements, people also found that these technologies have not yet evolved to the stage where they can provide you complete immersion. Some of the key developments from the 90s are now discussed. So, you can see here an image from Boeing in 1992. So, researchers at Boeing using a see-through HMD to guide the assembly of wire bundles for aircraft. You can see these wire bundles, and using this see-through head mounted display, they were getting guidance on how to actually assemble wire bundles inside an aircraft that Boeing was manufacturing. Here is an example of printer maintenance from 1993, is known as Karma. You can see here when a printer has paper jammed or it has gone faulty, this user which has head mounted display can actually see an overlay on what to do, so that he can fix the printer, which tray to pull out and what to do next. All of these steps are illustrated through this augmented reality overlay. This is a view inside of the mother's home from 1994. This was developed at the University of North Carolina at Chapel Hill, and you can see there is an overlay on top of the women's stomach that shows where is the likely location of the fetus. In 1995 came the Nintendo Virtual Boy. You can see an image of that here. Now, Nintendo was able to develop a 32-bit tabletop portable video game console. This was probably the first console which was capable of displaying stereoscopic 3D graphics. It had the ability to launch various games, some of which you may have heard, such as Mario's Tennis, Red Alarm, Tele-Robo Boxer and Galactic Pinball. You may have also heard about VR in popular culture from the movies such as Tron and the Lawn Mower Man. These are all built around stories where a person is transported into a digital world and leads a life there. Now, this also had a key influence on the public imagination of what VR technology promised. Now, the 1990s had various attempts at virtual reality, but many of them failed, and this was because of various problems such as low computing power, high latency, poor graphics, and the cost of these headsets and other accessories was quite high. So, this gave way to the late 1990s, which was a dull period for virtual reality. It can be said to be the first VR winter, and the key reasons, of course, we have traced them to unrealistic expectations of what people expected from VR technology. The hardware was limited, and the experience that the users were getting from such developments was poor. Now, that actually had some lessons to be learnt for people who are keen on taking this technology forward. So, technology alone is not sufficient. There was a need for better design, better hardware and better understanding of users, and that is also one of the reasons why we have actually come up with this course, where we are looking at the design aspect of AR VR. So, to summarize the timeline, 1838 we had the stereoscope, in 1962 we had the Sensorama come around, 1965 came around ultimate display, and 1968 we had the sword of Damocles. 1980s we had the period of VPL research and the coining of the term virtual reality, and in the 1990s we saw the first VR boom. Now, having understood this timeline, let us recap what virtual reality is. So, virtual reality immerses users in a fully computer generated environment, something we talked about in lecture 1. The physical world is replaced by a simulated digital space, and these experiences that you gain through virtual reality are typically delivered through head mounted displays, such as the one you saw today, me putting on the Quest 2, or the old ones such as even Sutherland's HMD, and typically these displays will come with motion tracking. Your sense of presence and immersion is crucial to effective VR design. So, if you want to be a good VR designer, then you want to be thinking about presence that you give to your users and the immersion that people have in the environment that you generate. Now, there are various competing terminologies to keep in mind. First is the virtual environment. The virtual environment can be considered synonymous with VR and is preferred by academic researchers instead of VR as such. So, the environment that you create digitally, that is referred to as a virtual environment. You can think of it as a difference between a photographically captured real world vis-a-vis a purely synthetic world. The next important terminology is augmented reality. It is essentially an interactive experience that combines the real world and the computer generated content. Another crucial term is mixed reality, which we understand as a merging of real world and the computer generated one. So, this could be thought of as either augmented reality or augmented virtuality. So, we can see today there are various terms in existence that people keep using, sometimes synonymously and sometimes wrongly. So, the distinctions between these terms have kept changing with time and sometimes eroded away. So, there are a number of terms that we can encounter in our day to day life. These include XR, which stands for extended reality, or X reality, VR AR or AR VR, used interchangeably, and sometimes VR/AR/MR to indicate the three different paradigms of virtual reality, augmented reality and mixed reality. So, there are the boundaries of our definition of VR that we need to think about. Would you consider listening to music and getting transported to another world using your headphones? Would you say that is VR? Or would you consider watching a movie at a theater as VR? Now, both examples use technology to provide artificial sensory stimulation, but can you call them as virtual reality? Or think about a portrait or a painting on a wall. It transports you to another realm altogether, perhaps to another century in the past. Would you call that as VR? How about reading a novel and getting transported to another location, another space, another time completely and getting completely immersed in that story? So, virtual reality involves the phenomena of fooling the brain. In real life, when any living thing explores its environment, neural structures known as place cells are formed. You can see those here, where a mouse is exploring a pipe, and as it is exploring a pipe, there are certain cells in the mouse's brain that get modified. These cells encode spatial information about the surroundings, and they are shown in different colors to represent the cells that are forming when the mouse is in different sections of this pipe. The place cells get activated when the organism returns to the very same place. In addition, there are grid cells. These encode locations in a manner similar to Cartesian coordinates. Now, it turns out that these neural structures, place cells and grid cells, may form even when you are undergoing a VR experience. So, indeed, when we explore objects in the real world, these sorts of cells are getting activated and they are storing spatial information. And equally, when you put on a headset and get a VR experience, the same sort of neural structures are getting created. So, is your brain getting fooled? Indeed. So, this phenomena of fooling the brain is what is essential to creating virtual reality. Let us look at what makes a VR system. We can think of a VR system as being made of the engineering bit and the reverse engineering bit. The engineering bit consists of your VR software and VR hardware, such as the headset that I showed you and any software that loads onto it. The reverse engineering aspect consists of understanding human physiology and human perception and tailoring it into the VR software and hardware. So, it is tempting to think only of software and hardware as making the VR system. The human, I repeat, the human is a key part of the system. Brought together, these form a tightly knit field of perception engineering, which involves using engineering methods to design, develop and deliver perceptual illusions to the user that fool the user. Let us look at what makes for standard VR systems. So, here you can see on the right HMD and wired gloves at NASA Ames, that is an example. So, VR headsets or multi-projected environments are part of these VR systems, and what they do is they generate realistic images which are shown on displays. They may also generate sounds and other sensations that simulate a user's presence in a VR environment. So, typically your VR headsets will use a head mounted display with screens in front of the eyes, or they may consist of rooms with large screens. There will usually be some audio and video feedback as well. They may also allow other sensory feedback such as force feedback and vibration feedback, and this happens through haptic technology or 3D touch. So, that can give you the illusion of the experience of touch that you experience in your day to day life. Now, we come to some applications of VR. So, VR may be used in simulation as well as training people to work in various work environments. It may be used for visualization in 3D as well as entertainment. A common application of VR is in 3D VR games which people enjoy playing. VR can help you remotely control vehicles such as drones. Of course, we can separate the entertainment aspect from gaming. So, entertainment may be limited to, let us say, movies, and we can think of another aspect of entertainment which is gaming. VR is increasingly used for surgery in operation theaters, in hospitals. It is used to give you architectural walkthroughs. For instance, you may suddenly be transported to the Salarjung Museum in Hyderabad, sitting wherever you are, or to the Taj Mahal in Agra, and you may be given a walkthrough which helps you experience these historic locations remotely, just as you do them in real life. VR is increasingly used to teach. So, it provides an immersive environment where people enjoy learning more than sitting in a normal classroom and learning from a teacher who is writing on a board. So, it can give you understanding of physics in 3D, it can give you understanding of how to create different chemical reactions, or it may give you understanding of various mathematical concepts. VR is also increasingly used for traveling to distant locations, and it can also give you immersive experiences that let you enjoy novel stories, etc., such as the trip down the rabbit hole from Alice in Wonderland. Maybe something for you to reflect on at this stage. Of all of the inventions that you saw here, which historical invention contributed most to modern VR? Now, to summarize what we learned in today's lecture, immersion indeed has a long history. We have traced the history until the end of the 1990s. Virtual reality emerged from many different disciplines. So, disciplines such as optics, such as physics, such as manufacturing, and so on and so forth. The early pioneers established what are the foundations of today's VR headsets, such as the one that I showed you in this lecture. It would be helpful if you actually look at this particular reference. There are a lot of details about these early inventions in Lavalle's book on virtual reality, which is freely downloadable. Stephen Lavalle is a professor at the University of Illinois at Urbana-Champaign, where I also happen to study. Now, before the next class, I would like you to research one historical milestone and prepare a 2-minute summary. Thank you for your attention, and I look forward to seeing you in the next lecture.